All right, this is going to be a little supplement to the trig substitutions, what we call lesson 6-3.5. This sort of has the look, but there are some other things going on here. And just by making a couple of adjustments here, we can rewrite this problem as a square root of 9 minus 25x squared, all raised to the third power. And there we see the origins of our triangle that we're going to need. Again, Nordstrom's stuck in the same triangle rut that it's always been. So our hypotenuse would be 3. One of the legs would be a 5x, which would give us the 9 minus 25x squared there. And if we're going to set this up, I don't know that I'll follow this all the way through, but definitely get it to the point where I feel like I'm probably going to rely on reduction formulas at some point. Maybe I'll feel frisky and want to do those as well. The square root of, so we want the adjacent over the hypotenuse. That looks like a cosine. Cosine theta is going to be the square root of 9 minus 25x squared over 3. So 3 cosine thetas are going to be equal to the square root of 9 minus 25x squared. And so I can rewrite my problem. I've got a 3 and a cosine theta, and the antiderivative, the cosine theta is actually being cubed, and we've still got the dx. We need to make that substitution for the dx. It looks like that's going to happen with an opposite over hypotenuse. So that's sine of theta is 5x over 3. So 3/5 sine theta is equal to x, and 3/5 cosine theta d theta is equal to dx. And so I'm going to have my 3/5 out in front here times the 3 that was already there. I still have this cosine theta in there, antiderivative of that cubed, and the rest of this is going to be in green for consistency. Cosine theta d theta. And so rewriting the whole thing as a new problem, that's 9/5 antiderivative of cosine to the 4th theta d theta. That would require, of course, one of our reduction formulas. To do that, I guess it never hurts to show an example of a reduction formula again. So 9/5. The reduction formula for cosine to the nth starts with a 1 over n, so that's 1/4. Cosine, reduce that power by 1, so that's going to be a cosine theta sine theta, plus 4 minus 1 is 3 over 4 times cosine squared theta d theta. Distributing everything through there now, I've got a 9/20 times a cosine cubed theta sine theta plus 27/20 times the antiderivative of cosine squared, which I can use my reduction formula again. That would be 1/2 times cosine theta sine theta plus 2 minus 1 is still 1/2. Antiderivative cosine to the 0, so just a dx in there, which is going to be x. And so I'm going to have a 9 over 20 cosine cubed theta sine theta plus 27/40 cosine theta sine theta plus 27/40 x. This is going to be a good example to do because that's not an x, that's a theta on there. plus a constant, because we're going to have to make a substitution for that theta as well. So we've got a 9 over 20. My cosine was square root of 9 minus 25x squared, so that's going to be 9 minus 25x squared, square root cubed, so that's to the 3/2 power over the 3 cubed, which is going to put a 27 down here, times my sine, which was a 5x over 3, plus 27 over 40 times the square root of 9 minus 25x squared over 3 times 5x over 3 plus 27 over 40. Now the easiest place for me to grab that theta is probably from this expression right here. So I'm going to say, because of what I see there, my theta is going to be an inverse sine of 5x over 3. So I'll put that inverse sine of 5x over 3 in here, plus the constant, and let's do one final run through simplification here. 27 times 3, these down here are going to make an 81, and so that's going to leave a 9 to cancel with that. These are going to cancel to a 9, so that looks like the 5 is going to do a little canceling here as well. So 4 times 9, I've got a 1 over 36, x times 9 minus 25x squared to the 3/2 power. All right, 5, that's going to cancel to the 8 again. 9, that's going to leave a 3. So this is going to be a plus 3/8 x times the square root of 9 minus 25x squared, plus 27/40 times the inverse sine of 5x over 3 plus a constant, and that is going to be my antiderivative of 9 minus 25x squared to the 3/2 power. What I should do is leave you to check that. You got to be able to check that. You can do that. And verify that that's actually what you get. That would be some phenomenal algebra practice that, that might be very beneficial to you at this point. All right. Good enough for now.